The modern sperm whale is a gentle giant. It dives 2,000 meters into absolute darkness, holds its breath for over an hour, and vacuums up squid with a mouth that barely has functional teeth. It's one of the most peaceful large predators on Earth. Its ancestor did none of that. 17.5 meters, 57 feet, longer than a semi-truck hauling a full trailer. 60 tons. That's 8 to 10 African elephants standing on a scale together. A skull 3 meters long, which is 10 feet, double the length of a T-Rex skull. And teeth, 40 of them. Each one 36 centimeters, 14 inches, longer than your entire forearm. While its descendants learned to hunt squid in the deep, this one stayed near the surface. And it stayed there because that's where the whales were. Meet Livyatan melvillei, the sperm whale that hunted whales. 12 million years ago, the oceans looked very different. This was the Miocene epoch, specifically an age called the Tortonian. The continents had mostly settled into familiar positions, but the climate was warmer, the sea levels higher, and the coastlines absolutely teeming with life. Cold, nutrient-rich currents surged up from the deep along continental margins, a phenomenon called upwelling. And wherever that happened, you got an explosion of productivity. Plankton blooms, fish schools, and whales. Lots and lots of whales. Small baleen whales called cetotheriids cruise these waters by the thousands. 5 to 8 meters long, slow-moving, packed with energy-dense blubber. They were the cattle of the Miocene seas, abundant, nutritious, and not particularly fast. Perfect prey for anything large enough to catch them. Most of what we know about Livyatan comes from Peru, specifically a geological formation called Pisco. It's one of the richest marine fossil sites on Earth, a window into this ancient ocean preserved in stone. But Livyatan wasn't just a Peruvian phenomenon. Teeth matching its size and structure have turned up in Australia, California, Chile, Argentina, and South Africa. This wasn't a local monster. This was a global apex predator. The name tells you everything you need to know about how paleontologists felt when they found it. Livyatan is the Hebrew spelling of Leviathan, the biblical sea monster. The species name, melvillei, honors Herman Melville, the author of Moby Dick. The irony is almost painful. Melville imagined a terrifying white whale that could sink ships and haunt the nightmares of sailors. The real thing would have eaten Moby Dick as a light snack. Here's what makes Livyatan genuinely strange from an evolutionary perspective. It belongs to Physeteroidea, the sperm whale superfamily. Modern sperm whales are specialists, deep divers with reduced teeth, built for sucking squid out of the abyss. But 12 million years ago, that family tree had a very different branch. One that kept all its teeth. One that coated those teeth in enamel for cutting through flesh. One that looked at the whales swimming at the surface and saw not relatives, but groceries. The modern sperm whale dives 2,000 meters to find food. Livyatan didn't need to dive at all. Its food was swimming right there at the surface, and it was delicious. Here's the challenge with Livyatan. We don't have a complete skeleton. The star specimen, discovered in Peru in 2008, consists of a skull that's about 75% complete, some jaw fragments, and teeth. That's it. No vertebrae, no flippers, no tail. So every estimate of total body length requires comparison to related species. And depending on which species you choose as your reference, you get very different numbers. The conservative estimate uses modern sperm whale proportions. Sperm whales have enormous heads relative to their body length, roughly 1/4 to 1/3 of total length. If Livyatan followed the same proportions, a 3-meter skull gives you a total body length of around 13.5 meters. That's 44 feet. Still impressively large, but comparable to a humpback whale. The more generous estimate uses zygophyseter, an earlier macroraptorial sperm whale that's more closely related to Livyatan in terms of lifestyle and skull shape. Zygophysator had a proportionally smaller head compared to its body. If Livyatan followed that template, you're looking at 17.5 meters, 57 feet, comparable to the largest Megalodon estimates. The scientific consensus lands somewhere between those extremes, accepting a range of 13.5 to 17.5 meters for an adult Livyatan. At the upper end, we're talking about an animal as long as a semi-truck with a full trailer attached, 3 times the length of a great white shark, longer than most humpback whales. Weight estimates cluster around 50 to 60 metric tons. That's 110,000 to 132,000 pounds. Picture 8 to 10 African elephants all standing on the same scale. Or, if military hardware is more your reference point, one M1 Abrams main battle tank. 4 fully loaded school buses stacked together. The skull alone was 3 meters long, 10 feet, taller than an NBA center lying down. Almost 2 meters wide at the cheekbones, wider than a king-size bed. For context, Tyrannosaurus rex had a skull about 1.5 meters long. Leviathan's was double that. So we're talking about an animal the size of a whale that made its living eating other whales. The energy requirements for something like this are staggering. A warm-blooded mammal this size needs constant caloric input just to function. The solution was elegant: hunt the most energy-dense prey available. Blubber is essentially stored calories, and cetotheriid whales were swimming buffets. 60 tons of warm-blooded predator requiring constant fuel. Let that sink in for a moment. Then consider what it had to eat to stay alive. But size alone doesn't make an apex predator. Plenty of large animals are gentle. What made Livyatan terrifying wasn't just its mass, it was what evolution put in its mouth. The teeth tell the whole story. Maximum recorded length, 36.2 centimeters, that's 14.3 inches, longer than your entire forearm, wrist to elbow. Diameter, 12 centimeters, about 5 inches, the width of a salad plate. And here's the record that matters. These are the largest functional teeth of any animal in Earth's history. Functional is the key word. Elephants have longer tusks. Walruses and narwhals have impressive ivory. But tusks aren't used for feeding. They're display structures or tools. When we're talking about teeth actually used to kill and eat prey, Livyatan stands alone. T-Rex maxed out at 30 centimeters. Megalodon's teeth, even including the root, topped out around 18 centimeters. Livyatan's were 20% longer than the Tyrant King's and double the length of the largest shark teeth ever found. The distribution was comprehensive: 9 teeth on each side of the upper jaw, 11 on each side of the lower, 40 teeth total, all deeply rooted into solid bone, designed to withstand enormous mechanical stress without ripping loose when prey struggled. But the really telling detail is the enamel. Modern sperm whales have little to no enamel on their teeth. They don't need it. They swallow squid whole using suction, a feeding method that requires no cutting, no puncturing, no shearing. Their teeth are almost vestigial, pegs that barely emerge from the gums. Livyatan's teeth were coated in thick enamel on every surface. Enamel means hardness. Enamel means these teeth were designed to puncture tough material and slice through resistant tissue. The wear patterns confirm it. Heavy facets where upper and lower teeth met repeatedly, evidence of a shearing action like industrial scissors cutting through whale flesh. The engine driving these teeth was equally impressive. The temporal fossa is a depression in the skull where the major jaw-closing muscles attach. In Livyatan, this depression was enormous, larger than a human torso. More muscle attachment surface means more muscle, and more muscle means more
bite force. Exact numbers are debated because we lack a complete jaw for full biomechanical modeling. Some studies estimate static bite force around 10 to 11,000 newtons at a single tooth point. Others suggest the total force during an actual attack with momentum, acceleration, and dynamic loading could approach or exceed 100,000 newtons. For scale, a human bite generates about 700 newtons. A lion manages around 4,500. A saltwater crocodile, famous for its crushing jaws, produces 16,000. T-Rex has been calculated at 35 to 57,000 newtons. Megalodon holds the record at 108,000 to 182,000 newtons. Livyatan was competing in that weight class, with teeth twice as long, the largest functional teeth of any animal ever. 40 of them, backed by jaw muscles the size of your entire body. And we haven't even gotten to how it used them.
Having weapons is one thing, deploying them effectively is another. And Livyatan had a targeting system that nothing else in the Miocene ocean could match. Running along the top of the skull is a massive, bowl-shaped depression called the supracranial basin. In modern sperm whales, this houses the spermaceti organ, a complex structure of oil and wax that generates and focuses sound for echolocation. Livyatan had this feature too, and it was enormous. Echolocation works by emitting clicks and reading the returning echoes. It's biological sonar, building a three-dimensional map of the environment in real time. Modern sperm whales use this to hunt squid in total darkness 2 kilometers down. Livyatan used it at the surface, where visibility might be limited by sediment, algae blooms, or simple distance. The tactical advantage is hard to overstate. Megalodon, for all its power, relied on electroreception, sensing the electrical fields generated by muscle movement and smell. Both are effective but relatively short range. Livyatan could detect prey from hundreds of meters away, track its movement, gauge its size, and coordinate an approach before the target knew anything was wrong. Imagine being a cetotheriid whale in the Miocene Pacific. A 60-ton predator knows exactly where you are, how fast you're moving, and how many others are swimming with you. And you have no idea it's there. It's the difference between a surface ship relying on lookouts and a submarine hunting with active sonar. The skull anatomy suggests another weapon. Notice that Livyatan's teeth are set back from the front of the snout. The rostrum, the forward portion of the skull, is robust, reinforced, built to absorb impact. Some researchers have proposed that the head itself was a battering ram. This isn't as speculative as it sounds. Modern male sperm whales regularly ram each other during competition for mates, sometimes with enough force to cause serious injury. In 1820, a sperm whale famously sank the whaling ship Essex by ramming it twice. Fossil marine reptiles like mosasaurs show skull damage consistent with ramming behavior. The anatomical equipment for this strategy is clearly present in Livyatan. The proposed attack sequence goes something like this. Detect prey with echolocation, approach at high speed, strike the target in the flank with a head-first impact to stun and injure internal organs, then move in with the teeth to finish the job. A 1-2 combination, concussion grenade followed by chainsaw. The kill itself was straightforward brutality. Grip the prey with those 40 interlocking teeth. Use 60 tons of body mass to rip free massive chunks of tissue. Target zones with major blood vessels, behind the flippers, the belly, the throat. One good bite could remove enough tissue to cause fatal blood loss within minutes. Modern orcas use a similar technique, sometimes adding a twisting motion, a death roll, to maximize tissue damage. There's no reason to assume Livyatan didn't do the same. And then there's the pack hypothesis. Modern sperm whales are intensely social animals. They communicate with complex clicking patterns, form stable family groups, and cooperate in raising young. Livyatan's echolocation anatomy suggests similar communication capability. If they hunted in groups, the tactical implications are terrifying. coordinated herding of prey, multiple attack angles, the ability to overwhelm even large whales through teamwork. No direct fossil evidence confirms pack hunting yet, but the anatomical foundation is there. The scariest thing about a 60-ton whale killer might be that there were several of them working together. So let's recap. You've got a 60-ton whale that can see through murky water from hundreds of meters away, might use its own head as a battering ram, potentially hunts in coordinated groups, and carries 40 teeth the size of steak knives. The Miocene Ocean was fun. This hunting system was so effective that for millions of years, only one thing in the ocean came close to matching it. And even that thing kept its distance. Otodus Megalodon needs no introduction. The largest shark that ever lived. The star of movies, documentaries, and internet arguments about whether it might still be lurking somewhere in the deep. It wasn't, but that's beside the point. What matters here is that Megalodon and Livyatan shared the same waters at the same time. Both species appear in the Pisco Formation. Both have been found at sites around the world dated to the late Miocene. Both were hunting the same prey, small baleen whales. And both were operating at roughly the same size class. The comparison is irresistible. Megalodon might have been slightly larger at maximum. Estimates range from 18 to 20 meters, perhaps 50 to over 100 tons, depending on the reconstruction. Its bite force was almost certainly higher, calculated at 108,000 to 182,000 newtons, based on jaw mechanics. It was cold-blooded, meaning more energy efficient, able to go longer between meals. Livyatan had different advantages. Its teeth were longer, 36 centimeters versus 18. It was warm-blooded, meaning faster metabolism and higher sustained activity levels. It had echolocation, providing superior detection range and environmental awareness. And it had a mammalian brain. Not just bigger than a shark's, but fundamentally different in architecture, capable of learning, problem-solving, and complex social behavior. On paper, a direct confrontation could go either way. In practice, it probably rarely happened. Apex predators don't generally fight each other unless forced. The risk-reward calculation doesn't work. Even winning a fight with an equal can mean serious injury. And a wounded apex predator is a dead apex predator. You can't hunt effectively with torn muscles or broken bones. The energy cost of healing is enormous. Better to avoid the confrontation entirely. Most likely, Livyatan and Megalodon practiced mutual avoidance, steering clear of each other, claiming different territories, ceding contested prey to avoid escalation. But the ecological pressure was real. Both needed enormous amounts of whale meat. Both were competing for the same finite resource. The ocean couldn't support infinite populations of both. Occasional confrontations over carcasses, over territory, over the protection of young, these must have happened. We just haven't found the fossil evidence yet. Two apex predators, one ocean, millions of years of coexistence. Something had to give eventually. But here's the thing. When Livyatan was at its peak, at the absolute height of its power, even the largest shark that ever lived thought twice before engaging. So put it all together, 60 tons of mass, a skull twice the length of a T-Rex's, 40 teeth, each one longer than your forearm, coated in enamel designed to shear through whale blubber and bone, jaw muscles larger than a human torso, echolocation capable of mapping the ocean in 3 dimensions from hundreds of meters away, a robust skull that may have doubled as a battering ram, a warm-blooded metabolism driving constant activity, a mammalian brain capable of learning, adapting, coordinating with others, and possibly, probably, others just like it swimming alongside. This wasn't just a predator. This was a weapon system. Picture it. A pod of Livyatan moving through the Miocene Pacific. The water is warm and green with productivity. Echolocation clicks ripple outward, a wall of sound mapping everything within range. Somewhere ahead, a group of cetotheriid whales, 6, maybe 8, feeding on krill near the surface, oblivious. The clicks change frequency. The pod has locked on. The approach begins. Silent, deliberate. 60 tons of mass building to ramming speed. The impact, the teeth, the blood clouding the water. This was the T-Rex of the ocean. This was what Herman Melville dreamed of when he wrote about the white whale, except the reality was worse than any fiction. This was 12 million years of evolution asking one simple question. What happens if we take a sperm whale and optimize it entirely for violence? For millions of years, longer than modern humans have existed as a species, the answer was Livyatan. And for all that time, nothing in the ocean could touch it. Not the giant sharks, not the other marine mammals, nothing. Livyatan wasn't just at the top of the food chain. Livyatan was the food chain. This wasn't just an apex predator. This was nature pushing the sperm whale body plan to its absolute limit. Maximum size, maximum weaponry, maximum aggression. An evolutionary experiment in marine mammal violence. And for an eternity by human standards, it worked.
But nothing rules forever.
The late Pliocene brought change. Global temperatures dropped. Ice caps expanded at both poles. Ocean currents shifted as passages closed and opened. The upwelling zones that had fueled the Miocene's productivity began to collapse or relocate. The cetotheriids, Leviathan's primary prey, crashed in numbers. The survivors migrated toward polar waters, following the cold currents that now carried the nutrients. Too far, too cold. Livyatan was built for warm, productive coastal waters. Its warm-blooded metabolism demanded constant fuel. When the buffet closed, there was nowhere to go. The last ones, like that tooth found in Australian sediments, dated to roughly 3 million years ago, swam in emptying oceans. Clicking into the dark, calling for pods that never answered. Orcas rule the oceans now. They're brilliant, social, adaptable. They hunt in coordinated packs and take down prey as large as blue whales. They filled the ecological role that Livyatan once owned. But orcas are 8 tons. Livyatan was 60. Nature doesn't build them like that anymore. Maybe the oceans can't support that kind of predator now. Maybe the energy math doesn't work in a cooler, less productive world. Or maybe nature just doesn't roll those dice twice. But for millions of years, longer than humans have walked upright, there was something in the ocean that hunted whales for a living. Something with teeth longer than your arm. Something that might have worked in packs. Something that made even Megalodon keep its distance. Livyatan melvillei. The Leviathan, the T-Rex of the ocean. Gone now, but not forgotten. Thanks for watching, and until next time.